Perdón, le quería enseñar algo.
Okay, ready? Ready? Okay. Again, I need to suspend the class at 12:30 because of your little festivity. Sí, también los quiero mucho todo, pero... Anyway, fine. The new topic for the second partial, first because the second partial is about definite integrals. Some of you have already seen something related to this in your projects, okay? So you're familiar with this, some others don't. So the idea is that we're going to see some examples and we're going to see properties tomorrow, and more examples on Monday. So 3 days for this topic, okay? Perhaps more, it depends on my meeting with Tiberi tomorrow, so it depends. Mañana me junto con Tibe para ver qué hacemos con respecto a los temas, a ver si los podemos. No, está fácil. Los que siguen a lo mejor. Creo que sí. O tienen tópicos ustedes. Okay, anyway, fine. For definite integrals, to understand this topic of definite integrals, you need to understand first the fundamental theorem of calculus. What's the fundamental theorem of calculus? This theorem is a theorem that basically encompasses both differential calculus and integral calculus in a single expression. What do I mean by that? You remember in differential calculus, past semester, the very basis for that were the derivatives, right? The derivative is basically an application or the way to solve the tangent line problem. Here in Math 6, for integral calculus, the core problem of the topic is the area problem. What's the area problem? The area problem states that if you have a function, any function, let's say f, there should be a way to calculate the area under that curve between a certain interval a to b. That's called the area problem. So this theorem of calculus was developed by Isaac Newton, physics one, Isaac Newton, one of the authors, something like that. And another mathematician that is called Gottfried Leibniz. That was that. They both developed this fundamental theorem in different places, in different moments, but they got that. So this theorem says that, for example, if I have a function f which is continuous, remember continuity from last semester? So if I have a function that is continuous in a center interval a to b, then I can get the antiderivative for that function. So integral of f of x dx is the antiderivative f of x, capital F of x. But if I have these two values, which represent the limits of integration, those are called limits of integration. So if I integrate that function, I get the antiderivative. But if I have limits of integration, I need to evaluate that function in those values. So now my answer is going to be f evaluated with b minus f evaluated with a. So the answer is going to be a number now, not a function. In the past topic, the answer was a function or a family of functions. But now, for definite integrals, the answer is going to be a number. Okay, what's the application for that? The application for this is that we can find the area below a curve, which we'll see later during the second part. Okay? So, the idea here, let's do some examples. I want to solve these two integrals. If you observe, there's a big difference between them. The limits. Here I have limits, here I don't have limits of integration. This one is called an indefinite integral. And this one is going to be called the definite integral. And how do I solve that? The same way I we have done so far, with the techniques, with the rules, with everything. So, here, for example, I want to solve this. What do I do? First, I rewrite, so it's going to be integral of x to the 1/3 minus 2 dx. Integral of that is going to be? X to the 4/3 over 4/3 minus 2x plus c. If I rewrite that, it's going to be 3/4 cubic root of x to the 4th power minus 2x plus c. And that's my answer. Yeah? A function plus c. In the second one, what are we going to do? We're going to solve it the same way, but the answer is going to be different. It's going to be a number now. So here, you rewrite that, blah, 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 so the answer is going to be the same. 3/4 cubic root of x to the 4th power minus 2x, but you don't put the plus c anymore. There's no need to. You're going to evaluate that between 1 and minus 1. You need to add this little line, because this line means that you're going to evaluate between 1 and minus 1. And then do it. You evaluate 3/4 cubic root of 1 to the 4th power minus 2 times 1 minus the same function evaluated with minus 1. 3/4 cubic root of minus 1 to the 4th power minus 2 times minus 1. Yeah, always minus. Always minus. Always minus. Okay? And then we solve it. This one is going to be 1 to the 4th power is 1, here is also 1, so 3/4 minus 2 minus 3/4 minus 2 equal to minus 4, which is a number. Okay? Why minus 2? Because it's minus 2 times minus 1 is positive 2 times minus becomes also minus. So the answer is minus 3. Okay? Questions? No? As simple as that. So there's a big difference. Indefinite integral, answer is a function plus c. Definite integral, answer is a number, no function. Yeah.
Si por ejemplo la C tuviera una condicional, ¿te la dicen primero o te ponen el ejercicio anterior donde sustituíamos integrales? Para explicarse.
Ajá, la que va a usar por parte del estudio. Yeah, you need to have the condition, not with values. That's different because in this case, as an application, this represents the area below that function if it goes to numbers, which is different to the particular solution because the particular solution gives you a function as an answer, which is different. Okay? So now we're not going to combine the two things. It's or particular related for indefinite integrals or definite integrals. Different stuff. Okay, questions? No? Sure? Marcelo, question?
No.
Okay. Let's try another example. Minus pi over 6 of secant of x. This one, for example, you have integral of secant square of x, but between minus pi over 6 to pi over 6. Those will be my limits of integration. What do I do? Solve it. Secant square integral is tangent of x, not fussy, evaluate between minus pi over 6 to pi over 6. So equal to tangent of pi over 6 minus tangent of minus pi over 6. What would be the value? The exact value, no decimals. So, no calculators. What would be the answer? Tangent of pi over 6, remember how to get it?
I already forgot the
Using the triangles, yeah. Using the triangles will be the special triangle of pi over 6, which is 1, 2, square root of 3. So tangent of pi over 6 is opposite over adjacent. So it means that we have 1 over square root of 3 minus tangent of minus pi over 6 is going to be minus 1 over square root of 3. So at the end my answer is going to be 2 over square root of 3. Rationalize. 2 over square root of 3 over 3. Do you remember that from Math 4?
O sea, primero recuérdame cómo, ¿por qué es el daño del piquito de arriba? Porque no puede ser de cualquier, bueno, excepto el ángulo.
Because this angle is pi over 3. Remember, we have a special triangle for 60, 30, and 80. Or 60 and 30, actually. Pi over 3 is 60. Pi over 6 is 30.
Ah, ok.
So that will be the measurement we get. It's a special triangle. Okay. Si no se acuerdan cómo sacar los triángulos, eso les recomiendo que lo repasen un poco. Si les puedo así meter más todavía de ángulos sin calculadora.
O sea, nosotros tenemos memoria.
No, se les enseñó. Luego conmigo no te encuentro en el verano, entonces yo les digo cómo sacar.
Es mucho.
Qué triste. Bueno, okay. Questions so far? No? Okay. Let's try more examples, but this time using one of the techniques. Substitution, by parts, the triangles, etc. Okay? To see what happens between them, we have definite intervals.
Profe, si sustituye al principio no se puede. Si le pongo los límites al principio antes de integrar no se puede.
No, different stuff. So there is a reason why to get into the derivative. We will see that later. Which is called using the Riemann sums. Riemann sums is the basis for this. You'll understand why to be like that. Okay. Let's try, for example, this one. Integral between 0 and 1 of x squared plus 3 to the, let's say, 4 power. Okay, that one. How do I solve that one? Not by one.
Substitution.
No, because you have a 4 power in there. Substitution. You will need to expand the binomial first, but it's not recommended. It's to the 4 power, it's too much. What's that? Yeah, observe the integral. The integral can be done with u/du. Substitution. Why? Because in this case you have a function which is this one inside the 4 power. The derivative for that is there. Yeah, or part of it because you have x. So, what? Yeah. Okay. du is what? 2x dx. There is no 2x, it's just an x. So what do you do with this one? You multiply. It's 1/2. To do what? To get rid of the 2. So now my integral is going to be 1/2 integral of u to the 4 du. Yeah? Okay, now, in this case it's substitution, but we have a little problem. Little problem. Very little. these limits. These limits here are limits in terms of the variable x, not for you. So you use a different stuff here. You use a different function, a different variable. So you have two options. One short one and a long one.
Short one.
First listen. The long one is ignore the values. Ignore the values, solve the integral denominator, find the integral, back to x and everything, and then put the values at the end, substitute. That's the long one. The short one is that I use the limits, I change the limits into terms of view. How? Pretty simple. Listen, these two values are in terms of x. So what I'm going to do, I'm going to put these values in this expression. So now I have values in terms of u. So now it's going to be u, let's call it u2 for this one, will be 1 to the square plus 3 is equal to 4. u1 I just put the limits inside the expression of u. So now I have the values in terms of u. So now my limits are going to be 3 and 4. So in this case, for example, what do I do now? I solve it. Integral of u to the 4 will be 1/2 u to the 5 over 5. But I don't need to go back to x anymore. Because now I can substitute directly here, 3 to 4. No need to go back to x. So now I have u to the 5 over 10 from 3 to 4 and solve it. So it's going to be 4 to the 5th power over 10 minus 3 to the 5th power over 10 and solve it. Remember, this is this with 4 minus this with the other one. And solve it. 4 to the 5th power. Yeah. 5th power should be
Profe, ¿solo se pueden 2 límites o se pueden 3, 4?
Equal to 781 over 10. That's my answer. Okay? If you can simplify, you simplify. In this case, for example, no, you can't.
Profe, ¿puede apañar?
Yeah. Where? You mean instead of this or what? No, that was the later. That's the second term. We'll see later. Next week. Fine. Questions? No? Sure? At the end, yes. Will you do more steps?
Profe, ¿no hay un plus de hacerlo largo? O sea, es lo mismo, no es de que si te viene esta, prefiere que hagas la larga.
No. In this case, I would prefer that you do this one to save time. But it's up to you. You get confused by this one, use the long one. So the integral the denominator, and then at the end the values inside. The answer is going to be the same.
O sea, la larga es como la normal, pues como la que tenemos acá.
Ajá.
Solo se puede cuando es u.
No, also with the terms. Trigonometric substitution. Actually, let's do one. And that's it. Can I hear it?
La derecha sí.
Yes. This one. Okay. Last example for today. We're ready to go. We're going to do trigonometric substitution one. Yeah, I know. So this will be a little challenging, okay? Not really experts on this. Integral of 3, 2. Okay, this one. Let's do this. This one is with the trigonometric substitution, right? It's one of the cases. So, from this, x is equal to what?
Formulary, sir.
You can use the formulary or you can use the triangle. So, we'll be going.
What is the
Square root of 3 times.
Secant o tira.
Yes.
You see why? If it was 4, this would be 2. If this is 3, not exact, so you indicate it. Square root of 3 secant. Dx. Secant, tangent, theta. Yeah. And the square root, x squared minus 3 is going to be square root of 3, what? Tangent. Good. So my new integral is going to be square root of 3 tangent times square root of 3 secant tangent, right? Over square root of 3 secant. I haven't put the limits yet, huh? Can I simplify that? Yeah, so this with this one, this with this one. So square root of 3 integral of tangent square theta d theta. Okay, so far? Okay, here comes the tricky part. Same situation, you have two options. You can do the long process, which is solve with the theta, and then go back to x, the triangle, to get the functions, and then solve it with the values. Or we can change the limits. Theta, in terms of theta, yeah. Right now, here, those two limits, 2 square root of 3, are in terms of x. This is my function that relates x and theta. So there should be a way to get the values in theta. How? Isolate. From this expression, theta is what? R secant, yeah, of what?
X over square root.
Okay, that expression. Now we're going to get the values, the limits in terms of that. The first one, the upper limit. R secant of 2 over square root of 3. I know that you're experts in trigonometry, so tell me, what would be the angle whose secant is 2 over square root of 3? Are you sure? No?
Es que según yo sí, pero
Yes, it is, but what?
es que por memoria, porque la otra fue 60, entonces la otra, o sea, la pasada de tangente era, eso es mi, no.
No, pues no es el mismo.
No, es que es diferente de la pasada. Entonces por eso, y como tiene un 3 y la otra es nomás, la de 45 es diferente.
Pero es que no puede ir hacia abajo.
The triangle again. Okay? This is 1, this is 2, this is square root of 3. Right? So tell me, because of the values that we have using this triangle, from this angle and this one, which of those two angles have a secant to be 2 square root of 3? 2 over square root of 3. 5 over 6. If you haven't got it yet, remember, what is secant in the triangle? Hypotenuse over what? Adjacent. Hypotenuse over adjacent. So, from this angle and that angle, this is the only one whose hypotenuse over adjacent is that one. Yeah? You remember that? Well, you should, huh? Because this is going to be the same. The other one, arcsecant of square root of 3 over 3, which is 1. So, not this triangle anymore, huh? Which angle its secant is 1?
¿Es un de 45?
No.
No. Impossible.
No, it's possible, of course. 0. Remember the unit circle from that form?
Yes.
No? You sure? O sea, en Mate 4, cuando ustedes vieron inversas, su maestro les debe haber dicho, cuando ven inversas van a ver los centros en cálculo. Y están en cálculo, entonces, pues...
Que profe, cuando salimos a la escuela de información se nos sale de la cabeza.
Yo sé. Pero por eso es Mate 6, no Mate 1 otra vez. Es como continuidad.
Ya veo por qué dejan las tareas de verano.
¿Mandé?
Ya veo por qué dejan las tareas de vacaciones.
Anyway. En el ángulo de 0, que es aquí, ciclo unitario es 1,0 las coordenadas. La primera, la x, siempre es el coseno. Es el seno. Eso lo vieron en cuarto. Entonces, secante es el recíproco del coseno. Si 1 entre 1 es 1 también. Entonces, ¿qué ángulo su coseno es 1? 0. ¿Qué ángulo su secante es 1? También es de 0. 0. ¿Ok? Yo le recomiendo, por favor, que lo repasen. Si quieren, se lo puedo explicar en las orillas con todo gusto. Esas orillas, no en clase, porque en clase no tenemos tiempo. Ya pasaba Mate 4. Con sus maestros. Yo también les llevo en Mate 4 y lo recuerdo bien que se los dije. No van a dar en cálculo. Okay, so those are my new limits. So I need to integrate this one. What do I do to integrate tangent square? There's no direct integral, so I need to do something else. You separate, yeah. Separate square root of 3 integral of secant square of theta minus 1 d theta. Okay, so this is 0 and pi over 6. Something like this was in your exam actually. So, integral of secant square is tangent. So, square root of tangent of 3 times tangent minus square root of 3 times theta evaluated from 0 to pi over 6. Yeah? Why this? Because of this. Why this? Because of the 1. Yeah? And you know, like, square root of 3 tangent of pi over 6 minus square root of 3 times pi over 6 minus square root of 3 tangent of 0 minus, well, 0. Tangent of 0 is also 0 minus 0, all of this is 0. Yeah. Tangent of pi over 6, what do you know? Square root of 3 times 1 over square root of 3 minus square root of 3 pi over 6. So the answer is going to be 1 minus square root of 3 times pi over 6. Give me a little later. Okay? Or the other option is the whole process, go back to x and evaluate. But at the end you still need to do this and the answer is going to be this. So you're not going to avoid this. You need to do it. Okay? Fine. Tomorrow we're going to continue with the topic, so bring the activity, please. Yeah. See you tomorrow.